Hi, my dear brilliant diamonds. Let us now discuss problem 1 of this exercise 1.2. But before proceeding further, I request you to watch the introduction video which we have done on this exercise. So, the required knowledge to solve this problem is you should know about co-prime numbers and you should also know about this theorem. So these are the things which we have already discussed in the introduction video of this exercise 1.2. Now we are going to prove this root 5 is an irrational number with the help of this basic knowledge. So before proceeding further, we welcome you to your favorite learning platform, Goodbricks. Right, let us now prove this root 5 is an irrational number. Now to prove that, we have a method called contradiction method. So as per that method, first we are going to assume this root 5 as a rational number. But what we have to prove? We need to prove it is a irrational number. So after assumption, this root 5 is a rational number. If it is a rational number, we can write root 5 is equals to a by b. That is what we can write. Where a and b are co-primes. It means a and b should have only one common factor. What is that? 1. Means other than 1, no other number should divide both a and b. So if root 5 is equals to a by b, and if you transpose this b towards left, you can write b root 5 is equals to a. And when you do squaring on both sides here, you can get 5b square is equals to a square. Let us assume this as equation 1. And we know already theorem. What is that? If a prime number p divides a square, then p also divides a. So when you apply this theorem here on equation 1, if 5 divides a square, then 5 also should divide a. So that is what we can get from this theorem. And that is what we are going to write here on the next step. Therefore, as per the theorem, 5 divides a square and also a. Let us write this as a condition 2. If 5 divides a, then we can write a is equals to 5 into something. That something is nothing but n we are writing. Means 5 into n is nothing is equals to a. So let us substitute this a is equals to 5n in equation 1. So where is the equation 1? See here. This is our equation 1. So in place of a, let us substitute 5n. So when you put 5n in place of a, we can write as shown here, 5b square is equal to 5n whole square. We just have substituted a is equals to 5n here. Now when you simplify, you will get b square is equals to 5n whole square. And when you look at here, b square is equals to 5n square, you can observe one thing. As per the previous theorem, previously we have discussed, 5 divides b square, then 5 also divide b. Now let us assume this as condition 3. Now here only the main twist of this problem comes. What is that? If you look at the second equation and third equation, from these two equations, you can clearly observe that 5 divides a, 5 also divides b. This is a big twist in this problem. Why? Because in the beginning, we assumed that a and b are co-prime numbers. It means they should have only one factor. What is that? 1. But from these two equations, we can observe that they have one more extra factor, that is 5. So if they have one more extra factor, then they should not be co-prime numbers. So that is what we have written here. But as per our assumption, a and b are co-primes, but they are not from these two equations. From equation 2 and 3, we can say that they are not co-prime numbers. Why? Because they have one more extra factor, 5. Hence, our assumption is wrong. What was our assumption? Our assumption was root 5 is a rational number. This is what we assumed. Since our assumption is wrong, we can write that root 5 is a irrational number. Hope you got good clarity on the problem which we have discussed. Thanks for watching and learning. Have a nice day.